Okay, so for today we'll be discussing about queues. Introduction. Queue is an abstract data structure somewhat similar to stacks. Unlike stacks, a queue is open at both its ends. One end is always used to insert data, or that is where we enqueue, and the other is used to remove data, or where we dequeue. Queue follows first in, first out methodology. That is, the data item stored first will be accessed first. A real-world example of queue can be a single-lane, one-way road, where the vehicle enters first, exits first. More real-world examples can be seen as queues at the ticket windows and bus stops. Queue representation. As we now understand, in queue, we access both ends for different reasons. The following diagram given below tries to explain queue representation as a data structure. So as in stacks, a queue can also be implemented using arrays, linked lists, pointers, and structures. For the sake of simplicity, we shall implement queues using one-dimensional array. So again, if we're going to look at this diagram, we insert here and we dequeue, or we access data element here on the other end. So as differentiated with the stack, we only insert and access element on one end, but in a queue there are two ends. We have the front and the back, or front and the rear. So basic operations. Queue operations may involve initializing or defining the queue, utilizing it, and then completely erasing it from the memory. But here we shall try to understand the basic operations associated with queues. So what are the basic operations? We have enqueue, that is to add or store an item to the queue. And then we have dequeue, that is to remove and access an item from the queue. So there are a few more functions that are required to make the above mentioned queue operation efficient. These are the pick. So the pick get the element at the front of the queue without removing it. Isfull checks if the queue is full, and then isempty checks if the queue is empty. In queue, we always dequeue or access data pointed by the front pointer. And while enqueuing or storing data in the queue, we take help of the rear pointer. So first, let's take a look at our supporting function. So pick. So this function helps to see the data at the front of the queue. The algorithm of the pick function is as follows. So if we have this procedure, so this function just returns the data at the front of the queue. So it says you return queue. Let's say the queue is the name of the array, and we return the element at the front of the queue. So in C language, almost similar. So what will be the code in C language? We have here integer pick. So this returns an integer value, assuming that the array we use is an integer array. So once we pick, it returns the element at the front of the array or the queue. So again, here we assume that the name of the array is queue. Then the next function is the full function. So as we are using single dimension array to implement queue, we just check for the rear pointer to reach at max size to determine the queue is full. In case we maintain the queue in a circular linked list, the algorithm will differ. So here, so how do we determine if it's full? So if the rear is equal to the max size, then we return true. Otherwise, we just return false. So implementation of isfull function in C language. So isfull, if the rear is equal to max size minus 1, then return true. If not, then we return false. Next, we have the isempty function. So how we determine if the stack is empty? So if the front is less than the minimum, or front is greater than the rear, then that means that the stack is empty. So return true if that's the condition. Otherwise, then we return false. So in C language, we have here a function that returns true or false. So that's why we have here Boolean data type. So if front is lesser than 0, that's lesser than the minimum, or front is greater than rear, then we return true. Else we return false. Then let's now take a look at the Enqueue operation. Queues maintain two data pointers. These are the front and the rear. Therefore, each operations are comparatively difficult to implement than that of a stack. So the following steps should be taken to enqueue or insert data into a queue. Step 1 is to check if the queue is full. So assuming that this is our queue, if the queue is full, then we just produce an overflow error and exit. So we should not be able to enqueue any data anymore if the queue is full. If not, then we increment the rear pointer to point to the next empty space. So let's say, for example, this is an array. So let's say the front index is 0, 1, 2. So 3 should be the next empty space, index 3. So what are we going to do? Increment the rear, so 0, 1, 2, then rear becomes 3. And then add the data element to the queue location. So we just place this data element on that particular location where the rear is pointing. Then return success, a feedback that means that enqueuing was successful. So let's now take a look at the algorithm and the C language equivalent. So check the algorithm. Procedure enqueue the data. So first we check if queue is full. Yeah, check if the queue is that's the first step. Check if queue is full. If queue is full, then return overflow. So if queue is full, produce overflow report. So that's our step. Then the third step, if queue is not full, increment rear. So in this case, we have here rear is equal to rear plus 1 to point to the next empty space. And then add data element to the queue location. So the data element will be added to the queue location where the rear is pointing. And then return success. So return true. So let's take a look at our C language program implementation. So first if, so check if the queue is full. So if is full. Then if that is true, we'll return zeros. So 0 will be our indicator that the enqueuing operation was not successful. So if not, if the queue is not full, then increment the rear pointer. That's why we have here rear is equal to rear plus 1 to point to the next empty space. And then the step 4, add data element to the queue location. So this is our data element. We added that to our array pointing to the rear location. And then we return 1 to indicate successful enqueuing. Then the next operation will be the Dequeue Operation. So accessing data from the queue is a process of two tasks. Access the data where front is pointing and remove the data after access. So we access and both remove the data. So in contrast with peek. So with peek, we only access but we don't remove the data. The following steps are taken to perform the queue operation. So the first step is to check if the queue is empty. So let's say if this is our queue, we first check if it is empty. So if the queue is empty, produce underflow error and exit. If the queue is not empty, access the data where the front is pointing. So in this image, front is pointing at A. Okay, so if we dequeue, we access A and increment front. So let's say assuming that front is at 0, so front now should be pointing at 1. That's why we increment front pointer to the next available data element. Then that's it. We return success. So let's now take a look at the algorithm and C language implementation of the dequeue function. So again, step 1, check if the queue is empty. So in our algorithm, if queue is empty, return underflow. So if queue is empty, produce underflow, error, and exit. So again, that is reflected in this pseudocode for our algorithm. And then if queue is not empty, access the data where front is pointing. So we get the data where the front is pointing and then store it in this variable. Then step 4, increment front pointer. So front equals front plus 1 to the next available data element. Then return true. So return success. So that was our algorithm. So in C language, let's check. The first step is to check if the queue is empty. So we have our isempty function. If it's empty, then we just return 0. So if queue is empty, produce an underflow, error, and exit. So 0 here will be our indicator that the dequeuing operation was not successful. Then if queue is not empty, so otherwise, if this is not true, access the data where front is pointing. So queue front, that will be the element on that particular location, front location, will be stored inside the data, the variable data. And then increment front pointer to point to the next available data element. That's why we have here front is equal to front plus 1, and then return success. So we just return the data that was queued. So that ends the more or less the algorithm for queue, dequeue, and other supplementary functions for the queue data structure. So thank you.